Good morning, dear students. Myself, Devraye-Patil, Head Department of Chemistry, Late Rameshwar Kulkarni CS College, Sonpet. We studied the atomic structure and wave mechanics. We already see the Planck's quantum theory, Einstein's theory, de Broglie's hypothesis. De Broglie explained theoretically the wave and particle nature of light, and Germer experiment which prove experimentally the wave nature of light. Today we will see the Heisenberg uncertainty principle. In that principle, this principle based on the quantum mechanics and which describe mathematically the properties of submicroscopic particles. So, in the atom, electron have precise orbit. To describe such an orbit would require knowing its exact position and the velocity, that is momentum. So, in 1927, Werner Heisenberg, from the its quantum mechanics, it says that it is impossible to know both position and velocity at a time, or which can shown simultaneously. So, the Heisenberg uncertainty principle states that it is impossible to measure or calculate the exactly both the position and momentum of an object. This principle is based on the wave particle duality of matter, which already seen in de Broglie hypothesis. Although Heisenberg uncertainty principle can be ignored in the macroscopic objects, since atoms and subatomic particles have very small masses, any increase in the accuracy of their position will be accompanied by an increase in the uncertainty associated with their velocities. So, the Heisenberg uncertainty principle for particle exhibiting both particles and wave nature, it will not be possible to accurately determine both the position and velocity at the same time. This principle is named after the German physicist Werner Heisenberg, who proposed this principle. He discovered that there were certain fundamental factors that limited our action in knowing certain quantities. Basically, this principle highlights that simultaneous measurement of position and momentum of microscopic matter waves will have an error such that the product of the error in the measurement of position and momentum is equal or more than an integer multiple of a constant. So, according to this principle, simultaneously position of electron in their atomic orbit and the momentum of that electron is not fixed or not certain. So, where we take The delta x is the displacement or error in position, and delta rho, it is the momentum, error in uncertainty in momentum is equal to h. Here we know h is the Planck's quantum, and the position and the momentum of electron in their orbit of an electron. So according to the Bohr's, the relation between the position and momentum is given as the uncertainty in position and the uncertainty in the momentum of a particle can be no can be not larger than h by 4 pi. This h by 4 pi given by the energy of orbit given by Bohr's. So this is the uncertainty principle of Heisenberg. For example, when m is large, that is mass is large, for example baseball or basketball, the uncertainties are small, but the electrons high certainty disallow defining an exact orbit. For example, we see uh, the example where the position of electron is measured. In order to measure the position of an object, a photon must collide with it and return to the measuring device. Since photon hold some finite momentum, the transfer of momenta will occur when the position collides with the electron. This transfer of momenta will cause the momentum of the electron to increase. Thus, any attempt at measuring the position of a particle will increase the uncertainty in the value of its momentum. That means at very small particles, when photons strike on electrons, the photons lose their energy and electrons get energy and increase their velocity, so that the velocity increases, so the position and the momentum is also uncertain. But in case of large object, for example baseball or basketball, the impact is negligible. While measuring the position of a basketball, there will still be a transfer of momentum from the photons to the ball. However, the mass of photon is much smaller than the mass of ball. Therefore, any momentum imparted by the photon to the ball can be negligible. So, in case of large object, this principle is not applied. This is the diagrammatically the diffraction of electron by a slit. The Heisenberg uncertainty principle will explained. The electromagnetic radiations and microscopic matter waves exhibit a dual nature of mass as well as momentum and wave character. Position and momentum of macroscopic matter wave can be determined accurately. Okay. The electron in an atom has mass 9.91 into 10 to the power minus 31 kilogram. In naked eyes, we will not be see such small particle. A powerful light may collide with the electron and illuminate it. The illumination helps in identifying, measuring the position of the electron. The collision of the powerful light source, while helping in identification, increase the momentum of the electron and makes it move away from the initial position. When fixing the position, momentum of the particle will have changed from the original value. Hence, when the position is exact, error occur in the measurement of momentum or velocity. In the same way, the measurement of momentum accurately will change the position. Hence, at any point in the time, either position or momentum can only be measured accurately. Simultaneously, measurement of both of them will have an error in both position and momentum. Heisenberg qualified the error in the measurement of both position and momentum at the same time. From this principle, we say the exact position of electron in the orbit of an atom is not fixed, because we know the electrons are revolving around the nucleus, and their momentum or their velocity also is not fixed. That means there is uncertainty in the position and the momentum of a revolving electron in the atom. So this principle give the mathematical expression which show the uncertainty in the position and the momentum, and that uncertainty is not greater than the Bohr's orbital energy, that is h by 4 pi. So students, studied this principle. Today I will provide you the PDF notes of this concept. So thank you.